Niamh said, my name is Fergal Reid. I work at a company called Intercom, and Intercom is trying to build the best AI customer support, customer service offering we can. We've been really busy working on modern AI, modern large language models, since last November when ChatGPT came along and OpenAI's new models came along and really changed everything for us. And so we've done about 2 product development cycles so far. And so I guess this talk is kind of the high-level view of the world that we have now after a couple of product development cycles. And my goal here today is to try and, I want to give a little bit of like thought leadership type stuff, but I also want to like really ground things. I want to really kind of go into a little bit more technical detail or practical detail to try and be like, hey, these are things we didn't know ahead of time that have surprised us and changed things for us. So with that, I thought it might be fun to just say, hey, this is GPT-4. And you say, what is Fergal Reid's biography, right? And I think, this is the example we see. It's definitely about me. It talks about a very specific paper I wrote doing research at the end of it. But then it also makes a lot of stuff up. It's also got a lot of things that are not about me, that are plausibly things that someone like me could have done, but have nothing to do with me. And so this is this problem of like hallucinations, and this is a key topic that I want to address in this talk. And I would say my high-level summary of the talk is like, you can look at these large language models and GPTs at several different levels. The first level is like, wow, ChatGPT came out, this is amazing. But then, a level beyond that is like, wow, okay, this makes things up and it's not trustworthy. But I would kind of argue that we got to get back to this level 3, where if you look at it right and you start to see not the product ChatGPT, but the engineering tool set underneath it, you can build a lot of amazing products with this. And when you look at it right, so I would say, it's easy to underestimate these GPTs. You've got to consider them not as just the product you've seen so far, but as engineering components, systems that you can go and you can build full products around. And also, I think a lot of people are getting confused in the narrative around GPTs because we're failing to separate out a bunch of things they do that have kind of been accidentally bundled together. So let me try and explain that. So we start off with what is GPT, and a lot of people will start talking about, it's a sequence model that uses attention, it's trained by gradient methods, a whole bunch of like low-level machine learning stuff, which is true, but isn't useful. It's not a useful framing. And I think this is tripping a lot of people up in the wider narrative around it. So, in the spirit of all models are wrong, some are useful, right? What's a useful way to think about these things? Talking about the low-level building blocks, I argue, is like describing a human by talking about genes and evolution, right? Technically, if you've got the DNA of a human, you can learn a lot about them. But it fails to capture the right high-level framing, the right way of thinking about things. Again, like trying to approach psychology from genetics, right? Because really, the right way to think about these things as emergent systems, right? Yeah, they have a low-level architecture. We can talk a lot about like, hey, these things are built by, to learn to predict the next word. But what's important is what they can do. And so what do we mean by an emergent system? Well, we don't mean it's magic. There's nothing magical coming on. The higher level things they do, the kind of the reasoning and the understanding that we see emerging from these systems, it's not magic. It happens from how we train them. But how we train them doesn't capture what's interesting about these systems. And I would say the trust-standing narrative that starts off with, oh, these systems definitely, they can't understand things, or they can't do, reasoning, they can't do uncertainty, because all they do is predict the next word. These systems are trained to predict the next word or the next token, but that's not a good way to think about what their limits are. I would say instead, it's good to think about these systems as kind of like a combination of a database and a reasoning engine. So like a large language model stores a lot of data. You train it on all the data across the internet. It stores that data, but I think it's really helpful to split out the idea that, hey, it stores data, but then also it can reason. It can do intelligent tasks. And I think a lot of people are getting tripped up by focusing on the database. Because these large language models, they're not very good databases. They're not very good at storing and retrieving information accurately. They're very, they're they can store a lot of data, but they do it unreliably. They do it very fuzzily. But the reasoning engine, their ability to reason is new and amazing, and we think kind of an internet scale change. Often in pragmatic settings, when you want to actually use these to build products, the database, the fact that they store data, is almost a liability. So I just want to illustrate the reasoning capabilities here. I've made some big claims here. I'm saying, hey, these things are really good at reasoning. I just want to give an example of this. Hopefully without falling into the emerging large language model talk anti-pattern, which is to just read a lot of output from GPT. Promise there won't be too much of this. But basically, you can set up a simple reasoning scenario. A mouse wants to steal a piece of cheese. There's a cat in the room, there's a bell in the room. What should the mouse do? If you prompt GPT-4 with this, it'll give you, a plan. It'll say, wait for the cat to sleep, move quietly, avoid the bell, grab the cheese. You give it a fact that updates its, what's going on in the setting, and it's like, okay, you say the cat's deaf. Well, now it no longer needs to worry about moving quietly. You say, what about the bell? And it says, ignore the bell. Reason, the cat is deaf. The bell sound won't alert it. Why am I laboring this? Because getting a machine learning system to do this sort of reasoning in the past was extremely hard. And you could do it, you could kind of like set things up for it in a very simple way and have it try and use rules of logic to reason about things, what's going on. But it never really worked in any sort of a real world setting, or any sort of a setting where, there are many objects and you have to kind of reason approximately. But these new large language models, they can do that. And yes, they do store data, and you can pull data out of them. But I would almost say we should forget about that, and we should really focus on their ability to reason. That's what's new and what's amazing here. I want to give you another model. I'm going to give you several different pieces of information and then try and stitch them together with some products that we've built. Another model here to think about what these large language models are good and bad at is interpolative versus extrapolative tasks. Right? What do I mean by that? So, in machine learning, we talk about interpolation versus extrapolation, right? Maybe you have a whole bunch of data, and interpolation is like, hey, figure out, like, make a prediction about something that's, in the neighborhood of the data that I've seen before. And extrapolation is more like, hey, make a projection, maybe about, an area I haven't seen before. And this kind of slide captures it here. Fit a curve. Extrapolation is like something in the distance I haven't seen before. Make a prediction for that. And actually, as an aside, this chart, this is a fairly standard chart in maths. And I went looking for this on Google, and I couldn't find it. The fastest way for me to create this chart was to go to GPT-4 and say, hey, I need a chart that looks a little bit like this. I described it in English. It wrote the Python code that generated this chart and thought, oh, I'll put that in. That's an interesting thing. This is extremely powerful stuff. So interpolative versus extrapolative. It's good for tasks that are interpolative in some sense. So how do you do that? How do you take like a real business or a real product thing you care about and frame it as an interpolative task? Well, you want to get it to perform a task given a context, right? These large language models, when you use them with an API or when you ask them to do something, you can give them a whole bunch of information. If you've used ChatGPT, instead of saying to ChatGPT, hey, tell me something about Paris, France, instead say, here's the Wikipedia article about Paris, France. Now answer some questions about Paris, France. Because then what it knows or it doesn't know isn't so important. What's important is its ability to reason and to pick facts out of the kind of context it's been given. And so, these things get extremely powerful when you ask them to do a task given a context, given relevant information. And there's some human intuition that kind of makes sense here, right? If you had a history expert in a particular area, and you asked them to answer a historical question or to write an essay. In fact, if you studied history in school maybe a while ago, and I'm like, hey, write an essay on something you've studied, you're going to get things wrong. They're going to feel like hallucinations. You're going to write things down that are plausible but wrong things you've recollected. Whereas if you get a human and you say, give them a history book about a particular episode, and then you ask them to answer questions with reference to that book, well, they're going to look things up. They're going to give you the answer then. It's going to be much more grounded. It's going to be much more real. And so, like, the large language models, that they need context, is actually very natural and very human. So you only pass a limited window of context to these things. You can kind of think of it like as thousands of words, right? You can't put a whole knowledge base of context into these systems. But what everybody is doing, this sort of emerging paradigm now, is you use something like vector search, or basically some way of like, hey, I want my GPT to do something for me. Well, I want to shortlist relevant context and then ask it the task. So I have some other more traditional system that like shortlists the relevant context and sort of builds all the context for a particular task I want to do. This can be if you're asking it to answer questions for you. It can also be if you're like saying, hey, I want to use these models to figure out how to take action in the world. Well, build some other system that like shortlists all the relevant things that they might want to know or might want to operate with, and then ask them to make a decision, then ask them to do something. So we've done about 2 cycles of product development with these systems. I'm just going to talk you through what we've built concretely to kind of show you what you can achieve with these things, and to kind of make the argument that like, wow, yeah, these are capable technologies that you can build really amazing products with. So the first features we built at Intercom, we have a whole bunch of support reps who spend all day, every day, kind of answering customer support questions. We started off by trying to build simple interpolative features, right? And these are the sort of features, I think, to start out with. If you're in product development and you're trying to build something amazing with this tech, or if you're interested in what's likely to come fast with this tech, next 6 months, next year, you're going to see a lot of features like this, where it's like, hey, these are features where the tech is just kind of good at out of the box. So we built features to enable people to like summarize a conversation. So a support rep can like write a summary of a conversation before they hand it off to another customer support rep, a task that people need to do a lot. Or to like edit the tone of voice of something they've just written. And those first 2 features are quite interpolative. The next feature we did was to expand, to write like a shorthand version of a reply to a customer, and to try and expand that and make it bigger. That's more extrapolative. It doesn't work as well out of the box. So really what I'm kind of going with here is that, hey, this new technology can be used to build easy or hard features. Easy features, hey, out of the box, the accuracy is high, the cost of an error is low. Draft me a summary is an example of that. The human is going to approve the summary. They have the ability to edit it. Whereas hard features, features that are going to require multiple product development cycles, their accuracy out of the box is low, the cost of an error is high. And so, kind of expand this shorthand, this idea that a customer service rep could type a shorthand reply and then expand it out. You need a lot of context to make that great. You need to do a lot of other product development work to be like, oh, hey, GPT, here are other similar conversations that happened before. Here are like, canned ways that CS reps answer these questions. And so, again, we've got like ChatGPT, it's out there in the world. It's easy to look at that, and it's easy to underestimate the scale of the change we're about to see here, because when you actually work with it to do software development, you get an amazing building block that you can use to kind of like start off with like easy features, and then by doing some legwork and putting more and more data into it, be able to build quite substantial, quite hard features. And a bit like this quote from marketing, half the money I spend on advertising is wasted, I just don't know which half. It can be very hard to tell ahead of time whether something's going to be easy or hard. Is this something that is like, yeah, this is going to be in the sweet spot for this tech, or is it something that's going to require a lot of like time and iteration to make great? At Intercom, we've spent a lot of time recently building a bot that's definitely in the kind of the hard area of things. We call our bot Finn. And this is a GPT-powered question answering bot. And we were initially very reluctant to build this product. When we started using GPT 3.5 in sort of November, December, we were like, hey, we've got to build features for human teammates, for human support reps in the inbox, because we can't trust these models not to hallucinate. But then we got early access to GPT-4, and we got to play with that, and we kind of got better at using these models. And we really ended up building a bot that we think hallucinates very, very rarely, or I hesitate saying never because these models are imperfect, but seems to be and hallucinates seemingly similar to what humans do, basically. And we do this by, somebody asks a customer support question. We go and we shortlist all the articles in a standard customer support knowledge base, and we kind of pass them into GPT-4, and we ask GPT-4 to answer the question using just the information in those articles. And you end up with something that is AI, is modern AI, is conversational, answers people's questions, but just using the provided knowledge and the provided context. And that's pretty amazing. And I think this approach, and yeah, we built it. Loads of other people are starting to build these too. There's emerging paradigms to build all these things. This approach does kind of an end run around the hallucination problem that a lot of people are talking about at the moment. I guess thinking more broadly, going up from just the specific products and sort of our experience, we're really seeing the rise of agents. I think a lot of the narrative around large language models are treating them as inert things that they just generate text. They sit there and generate text. But that's a mistake. These things can be extremely easily turned into an agent that takes action in the world, and we're seeing that happen more and more. It's pretty easy to say, hey, the text I want you to generate is going to be like the name of an action that I want you to take next, from the following set of actions. And when you do that, suddenly you've got an agent that's deciding to take actions. And our bot Finn is built like this underneath the hood, and this is a very emerging paradigm. So I would say that when we're looking at GPT and ChatGPT, we shouldn't think of this technology change as like it's just an inert thing that sits there. It's a very general reasoning engine, and it can be used to power agents, software that goes and takes action in the world and takes action quite intelligently. And if you look at how OpenAI have built the ChatGPT API and how they've built the plugin architecture for it specifically, it's really a new way of building software. And it's really like, hey, hey, large language model, here are many different tools that you could have. Here's a description of how to access the tool in terms of the API calls you can make, and literally an English language description of what each of these API calls does. And then when you ask it to solve problems, the large language model chooses which calls to make and when, using its kind of built-in reasoning. And so this is really a new way to write software. It's something that's kind of very new and very different. We've deployed this sort of technique with Finn. I think you're going to see it everywhere over the next year. It's extremely powerful. And I guess, I guess a few kind of closing thoughts on the future outlook of this space. It can be hard to keep track of what's going on. Literally 2 years ago, we had early access to GPT-3, and we were kind of looking at it, and we were playing with it, and we were like, well, we had AI bots in production at the time, but we were like, oh, GPT-3 is just not ready. It's cool, it's niche, it does a lot of, generates a lot of plausible text, but it doesn't feel intelligent, it doesn't feel powerful. And then, like everybody else, we saw ChatGPT come out. We were like, wow, a threshold has been crossed here. It's extremely powerful. That was only 6 months ago. And then GPT-4 came out, sort of like February, late January, February. And it was clearly another huge step up in terms of reasoning capabilities from what we were seeing in ChatGPT and the ChatGPT APIs. So I guess the big, huge message here is a really, really important capability here. When you use it correctly, it's extremely powerful. And the space is just moving so fast. The amount of power and reasoning capability that's evolving is just incredibly fast. Over the last 6 months, the velocity has been very high. It seems reasonable to expect that to continue. Hard to say for sure. There's a ton of interesting stuff going on in the open source world. These models are getting faster and cheaper. Multiple vendors are producing them. And so I just think it's an extremely exciting time. So with that said, that's the end of my prepared talk. And we have about 5 minutes for questions. I think we had some questions. You have
3 there already, Fergal?
3 questions already, and feel free to submit more. Okay, lots to think about. What's the key question leaders should be asking around AI in 2023? Now, I would say this is extremely disruptive tech, right? Is it sustaining or disruptive? It's an extremely big technology change. And so I would really say is to look at your business, look at the tasks people are trying to do, and try and think like, how much of that could be automated? And again, don't fixate too much on ChatGPT, the product. Look at the power of AI to actually reason and be like, okay, if I had a really good reasoning engine that I could integrate into the task that humans are trying to do, whether it's my employees or whether it's software I'm building, how good could that get? Like, what sort of complexity could I end run around? Let me see. Oops, live QA. I'm just sorry. Okay. Thanks for the share. Do you have any fears that keep you up at night with what you're seeing in AI? I personally take AI safety and the sort of debate around that quite seriously. I don't ridicule that. Not quite at the point of keep me up at night, but I think it's really good that people are discussing threats of general intelligence. Speculative topic, but I don't ridicule that at all. Who do you see catching up with GPT, or are they just too far ahead of everyone else? Anthropic, who are another player in the space, have some very, very impressive models. I think GPT-4 is the largest, most powerful, most capable model that I've seen that's out there at the moment. Anthropic have extremely powerful models. And I think everyone who's a major player in this space is going to be spending a lot of money trying to train their own models, all the large cloud providers, for example. So yeah, I think we're going to see a lot of evolution in this space, would be my guess. What more does Fergal think we can do to iron out hallucinations from generative AI, improve the reasonings or the LLMs, or both, or something else? I guess the first thing I would say is that you can really build products that hallucinate very little in practice by carefully shaping queries and shaping the context, especially with very powerful and structural models like GPT-4. And I think that's a big deal. And after another couple of product development cycles, I think you're going to see that emerge a lot. That said, there's super recent stuff. OpenAI had a paper in the last few days about mathematical reasoning and trying to train the model to be correct at every step in the reasoning process rather than just at the end. So all the big players training these models are working on trying to iron out hallucinations even more from the core model. I do think they're a fundamental problem, but less devastating for product development than they first appeared, definitely. You got to work around them. Can you summarize how the reasoning engine works? No, and I think maybe what's interesting about this space is I think very few people can. I don't think anybody can, right? These are large language models. We know how they're trained, but we don't really know how the actual reasoning works in them underneath the hood. They're incredibly large, incredibly complex things that are difficult to reverse engineer. There's a bunch of work happening on that. We know a lot about them at a low level, but I don't think we know much about the learned architecture, about how they actually think as they go. You can ask them to explain their reasoning, but there's no guarantee that what they're telling you is actually what's correct underneath the hood. What percentage of the average workplace, take a supermarket for example, do you think will become AI roles in the next 10 years? That's a super hard question. I mean, if you look at a supermarket, obviously there's the self-serve checkouts are a big deal. That's even pre-AI. Beyond that, I mean, I honestly don't know. You're into robotics and things like that. I think a lot of software jobs that can be done end-to-end on software are going to see a lot of automation. That doesn't necessarily mean jobs are going to be lost. We'll just have to see. How long do you think it will take for AI to be as ubiquitous as Googling in business contexts? Not long. ChatGPT has got huge adoption, and again, it's getting faster, it's getting cheaper. I think you're going to see big players like Google react very fast to that. There's a unit economics problem with these models. They're expensive to run, but I think they will get cheaper, and there's already been huge decreases in costs. So yeah, I'll be excited that we'll be talking to agents that are intelligent rather than just Google pretty soon, or more intelligent than Google. Cool. I think that's all I have time for. Thanks a million, everyone, for your questions.